All right. Let's try the your turn on that same page. Oh, sorry, it's on the next page. This deals with exponential growth this time, rather than decay. Okay. Under ideal circumstances, a certain bacteria population triples every week. Wow. That's really fast. This is modeled by the following exponential graph, which you can see on your book. What's the domain and range? You tell me. What's the domain?
Oh, it didn't mean that. Everything.
What's the question?
I just wanted to know if you wanted us to tell you audibly or...
Yeah. Yeah, tell me audibly. We're going to do this together. I know it says your turn, but we're going to do it together.
Zero.
Anything greater than 0? Can it equal 0?
Yes.
Yeah, what's the variable? What should we use? T, W?
T.
T? Okay. This is time in weeks. Everything greater than or equal to 0. And it's a real number. Don't forget that. Range?
Anything greater than 1.
Could it equal 1?
Yes.
Yeah, it equals 1 at the start. So we start with 1, what is it, gram? No, 1 bacteria. Oh, nice. So you start with 1 bacteria. So what should we use? B? They use capital B. So B is greater than or equal to 1. Is it a real number? Think about that. Can you have like 3.56 bacteria? No. B here would be what kind of number?
Whole number.
A whole number. Actually, more specifically, a natural number, because you don't need 0. Woo! Interesting. You understand why? B can only be 1, 2, 3, 4, because you can only have 1, 2, 3, 4 bacteria. You can't have anything between that. Ben, that's what it says. Ben. B. Okay, so when it says write the exponential growth model that relates the number of bacteria to the time in weeks, what are they asking? The equation. Okay, so what is the equation? It'll be in this form, y equals c to the x. What is c? What would make sense? 3. Okay, give you a little bit of a hint. This value here is usually the rate at which something increases or decreases. So if I'm telling you something has a half-life or halves its population over every time interval, that would be C. If it triples, that would be C. Okay, that's the rate. A little bit of a shortcut there. So 3 to the x. And then C, determine approximately how many days it would take for the number of bacteria to increase 8 times the quantity on day 1.
So day 1 we have what, 3 bacteria?
Day 1 we have 3 bacteria.
Approximately 2 days.
Okay, so day 1 we have 3 bacteria. 8 times that will be 24. So we want to know when will the bacteria in this model, 3 to the t, when will we hit 24? What time interval?
Less than 3. A little bit less than 3.
A little bit less than 3?
Yeah.
Why?
Because 3 times 3.
3 to the 3 is 27, right? So a little bit less than 3 days. Okay? Alright.
3 weeks. Less than 3 weeks.
Oh, yeah, good job. 3 weeks.
And then if it wants to know in days.
So they want to know in days. How many days do you think? A little bit less than 3 weeks.
24 days.
24 days?
Wait.
That would be more than 3 weeks.
18 days.
So like 5 days.
19 days? A little bit less than 3 weeks. A little bit less than 21 days, right?
18 days.
Because 3 to the 3 gets us to 27.
Okay.
We want to be a little bit less than that, right? So it would be
19.5 days.
maybe 19 days.
19 days.
And again, how do you solve that, right? That's what next chapter is about. Logarithms. What are those?